I see why nobody does it this way. Ah, poop knuckles. Hello Internet, my name is Quinn and this is Blondihacks. Some projects work out better than others. I have a small footstock for my mill, but I have a setup where I need to use a footstock with my big 6-inch rotary table. So I decided to see if I could adapt the little footstock. Now, I got it done in the end and I got a setup that's going to work, but I learned a lot along the way and I would have done things pretty differently if I were to do this all again. So join me on this little journey and you can learn along with me. Let's go. Here's my Phase 2 4-inch rotary table. It's adorable, but it's a little on the small side for most jobs, and even after I knew that, I bought a footstock for it because, well, in my family, the sunk cost fallacy is quitter talk. So now I want to try and use this footstock with my 6-inch rotary table. Now you can see that this footstock is height adjustable. There's two inclined planes there that work together, but they only give you about 50 thou of height adjustment. So that's good news though that it has that, because it just means I need to get in the ballpark and then I can use that adjustment for the rest. I also have an alternate sneaky plan. I want to also set up this footstock for use with stock in collet blocks. I would like to be able to use tail support effectively on long parts that are in a collet block in the vise. So to do that, I need to get the tailstock elevated up to that level with a riser block, and I'd like to make a block that can also allow me to move this side to side because the T-slots never line up with stock that's in the vise. So I need to be able to adjust it laterally as well. So I had a plan to make two riser blocks, one for that case and one for the case over here on the rotary table. Now the rotary table needs a much larger block, but my thought was if I use a 1-2-3 block to take up most of that space on the rotary table, I can use a thin piece of stock and make both of these risers. Now I considered using steel. I have this chunk here, but I would need to make a longitudinal cut down it. Otherwise I'd be making chips for 2 days. Instead I bought this piece of drawn iron bar from McMaster Carr. It should be just the right thickness to where I can make both of these riser blocks. And again, one block will be used with a 1-2-3 block to get the much larger height needed. Now, this seemed like a good idea in past Quinn's brain. Turned out not to be such a good idea, but bear with me here. So I'll set this up in the bandsaw to cut the overall length here down to what I need. Because this is such a thin piece and it's cast iron, which cuts quite easily, the saw makes extremely short work of this. It chews through that very, very quickly. With a piece cut, I'm going to do a little mock-up here with this use case here. And the goal was to have a riser block that will get me basically on a center there with the footstock in the middle position. And unfortunately, even with the footstock in the highest position, it looks like it's still too low for that center mark. I put an indicator on there just to be sure, and sure enough, when it engages with the center on the work, I can see that it is lifting itself up a little bit. So I cannot get it high enough with this riser block. Basically, this means I mismeasured. I was sure that with this thickness of stock, I could get sufficient height for both of my use cases, and I just did it wrong. So I'm going to forego the vise collet block setup for now, and I'm just going to focus on getting the riser block going for the 6-inch rotary table. And I'm going to continue to use the 1-2-3 block strategy, but again, in hindsight, that wasn't a very good idea. Stay tuned for why. Now, because this is such a thin piece, I wanted to face the top first, so I tried to set it up like this in the vise, and wow, yeah, that saw cut is so crooked that the vise jaw couldn't grip it in that orientation, so I'm going to have to face this edge first. In almost every video, I talk about how great that 4x6 bandsaw is and how straight it cuts. Well, this time, for whatever reason, it didn't cut straight at all, so probably it was pushing too fast through the material there and the blade wandered a little bit. Those saws have a spring counterweight adjustment on them so you can slow them down, but I never bother with it. I'm not doing the textbook correct method for squaring stock here where you do a lap around one axis of the part squaring up each side and then using round bar or copper wire to take out the movement of the movable jaw and so on. I've done a video on squaring up stock the textbook way in my Mill Skills playlist, so check that out for that procedure. However, it doesn't work very well in this kind of situation where the stock is really thin, so I'm kind of cheating here and I'm not doing it that way. But that's okay because really all I care about is the parallelism of the two large sides, so I'm going to focus on those. I've got a big surface to face down there, but I have a secret weapon for this. This is a prototype of a facing mill sent to me by Shrum Solutions, Andrew Shrum. You can find him on Instagram. This is an insert face mill designed specifically for small milling machines, and it's such a great idea because tooling like this just really doesn't exist much for hobbyists. You've typically seen me use shell mills for this, and they work good, except that, you know, they're a little expensive and they're hard to regrind, so once you wear them out, well, yeah, it's a lot of money down the tube, potentially. So an insert tool is great. And I have to say this thing is working really, really well. I wouldn't want to go any larger diameter-wise with this machine, but doing a full 2-inch wide cut at 10 thou depth of cut left an absolutely stunning finish. Look at that. You can read the scale right there in the surface, and you know, this is cast iron right off the tool, no polishing. That's really quite remarkable. Now, obviously the inserts get the credit for the finish there, but this facing mill worked out really, really well. I'm very happy with this guy. You can buy those from Andrew Shrum. With that top surface faced, and I've got one edge cleaned up as well, I put those down and back in the fixed jaw there, trying at least to get this thing moderately square, even though squareness is again not super critical here. And I'm going to tappy tap tap that down, and then I'm going to face the other side. And then I'll face this final edge down to dimension. Now, you might be wondering, why did I go to all this effort to buy this special material for this instead of just using the steel that I had? A main reason is that with small machine tools like this, it really pays, I've learned, to minimize the amount of chips you have to make. Otherwise, these projects just take forever. These machines cannot take heavy cuts and cannot shift a lot of material, especially in steel and cast iron, things like this. So it really pays to try and buy stock that's close in dimension to your final product. But that does mean you take a risk like I did with buying stock that was a little too thin for that other application. With the two big faces cleaned up, that's the important part. Let's line it up on the surface plate now with my rotary table and see how I'm doing on height. I need to get the height correct, so it's just cleaned up now, but I know it's not to final thickness. So I can set it up here on the surface plate with a center in the rotary table there. That rotary table has a Morse taper 2 in it, which is great for this sort of thing. So I can put the height gauge on the tip of the rotary table center there, make a note of that reading, and then move it over to the footstock and measure the height of that center, and then the difference between those two readings tells me how much I have to take off of my riser block. Back over to the milling machine, and I can take off the rest of that material. Before I get too close to final dimension though, it's important to make sure I'm going to end up with these two large faces being super parallel. Remember, that's the important dimension here, because if these faces aren't parallel, then of course I'm introducing error in the orientation of the footstock. So when I'm close to final dimension, I take some measurements on thickness at both ends, and I can compare those and see how parallel the two faces are. And I see that I've got a couple thousandths of error here, probably mistakes in previous setups. So what I can do is just tap one end until an indicator shows me that I've got plus 1 thou at one end and negative 1 thou at the other. And then when I do this cut, it'll take that 2 thou parallelism error out of the piece. Little tricks like this are how you can get more precision out of low-end machines like this. Just check your work when you're close and you can make little corrections like that. And then I'll finish up by facing the two edges. Now that face mill that I was using was basically the exact same width as the material, which always leaves you with an extra nasty burr because it pushes the material over on the edge and doesn't really break it off. So I cleaned this up with a file. And because I was feeling frisky, I decided to draw file the edges a little bit, just to make them look a little nicer. Back to the surface plate now, and let's see how I did on my final dimensioning there. Again, this doesn't have to be dead nuts on because the footstock is set at its middle height position, so I've got plenty of wiggle room on either side, but if I can get these points lined up visually with the footstock in the middle, then I will feel good about it. And that looks very good indeed. So we'll definitely be able to dial in the height to be level with whatever setup we have now. Now the footstock has slots in the base for mounting it, and so I decided to replicate those slots with my riser block here, and that will allow me to just bolt straight through it. This seemed like a good idea, but it's actually not such a great idea, as you'll see here when I go to try and set this footstock up, but it does look nice and it was a fun exercise in cutting slots. Of course, since these are centered, it's easy enough to just run down to the other end and do the same thing. Next, I brought in my zero flute chamfering tool, and shout out to Bernie Solo for this little technique for chamfering a round-ended slot like this. You know, it's funny, I guess this is obvious probably to lots of people, but it just never occurred to me to use a chamfering tool this way to move it along a slot like this to chamfer all the sides simultaneously. It's a simple technique, it works really well, and for whatever reason just never occurred to me, so thanks, Bernie. Now you can see the setup that I was going for. It matches the base of the footstock perfectly there, which again, turns out not to be a very good idea. I didn't think this through very carefully beyond, oh, I'll match the footstock. And let's see how I did on parallelism here. So I've got a DTI on there, and I'm sliding the riser block under it, and I'm within a few tenths there all the way down, so that little correction we made at the end really did the trick. Now, that's a half thou indicator. I'm sure the tenths indicator would make a liar out of me, but let's just move on and pretend that I did it perfectly. I made some special T-nuts for this footstock. They are regular sized T-nuts with small 1/4-20 threaded holes in them because I'm going to use 1/4-20 threaded rod to hold this thing down. It's a good fit for the holes on the footstock, and it will also allow me to bolt through the 1, 2, 3 blocks. So I'm lining this up now, as you see here. And of course, these 1, 2, 3 blocks are a matched pair, but even if they weren't, I mean, if they're out by a few tenths or whatever, it's not going to matter. So I bolt this guy down, and now comes the tricky part. I have to get it squared up, and this is what I really wasn't thinking about. So I tried to do this by squaring up the 1, 2, 3 block first, and then squaring the footstock riser block to the 1, 2, 3 block, and then you got to square up the footstock to the riser block, or try to square up the footstock on its own first. Ensuring that the final footstock on top is square to the table was turned out to be pretty tricky the way I had done this. Normally a footstock and also the rotary table have keys on the bottom of them that align them to the T-slot automatically, essentially. And I just didn't think about that when I was designing this riser block, and kind of got myself into a little bit of trouble there. But I do manage to figure this out here, as you'll see here in a moment. The next step is to align the tailstock to the rotary table. To do that, I'm going to need an alignment bar. I found this chunk of aluminum that's the perfect length already cut. Aluminum's not the greatest choice for this sort of thing, but it was already cut and it'll be quick. So I'm going to face off one end and punch a number 2 center in it. Then I flip that around and do the same thing on the other side. The goal here is just to get 2 ends faced and with centers in them. It doesn't even matter if those centers are especially concentric. Now I take the chuck off and set up for turning between centers, because now we're going to make the real alignment bar. Regardless of how well aligned those 2 centers are, we're going to make them extremely well aligned right now. I'm using a drive pin there on the lathe mounting surface that I made specifically for this lathe, and I put the stock between centers there, and now I can turn down the OD. As long as this cut is deeper than whatever runout exists caused by misalignment between the 2 centers, then the resulting bar will be extremely concentric. So you can do that first step in a 3-jaw chuck, for example. Even if your 3-jaw has 5 thou of runout, the 2 centers will be misaligned by a few thou, but you're going to turn that out in this step, so it doesn't matter. The trick is that for this to be a valid alignment bar for a footstock, the diameter of this bar has to be extremely accurate and precise all the way down. And that means the tailstock on your lathe needs to be extremely well aligned. So really this is a good exercise to align your tailstock at the same time. Now I had 1.6 thou of taper in that, which is actually not bad for this length, but I can take that out by shifting my tailstock 8/10 inward to make the tailstock end slightly larger. And so you work the two set screws against each other with the tenths indicator on the quill there and lock it down, and then take another test cut and measure. And I didn't expect to get this in one. You never get it in one, but wow, I got it in one. I'd rather be lucky than good every time. This little hand gesture right here is the, well, I'll take it gesture. Amazingly, that bar is now within a tenth of the same diameter all the way down, and as a bonus, my tailstock is now super well aligned. How about that? Over to the rotary table now. I'm going to put my dead center back in there. As you saw before, there's a Morse taper 2 in that rotary table, so I can feed it through the chuck, seat it in the rotary table, and now I can insert the test bar that we just made here, and I can set up my footstock in the other end. And unfortunately, I didn't get the position of the footstock close enough, so I had to unbolt it and shift it into position, and then I had to go through all that process of squaring it up again. Yeah, I really should have designed a larger riser block that's one piece and has the keys in it and could be bolted firmly to the footstock instead of this mess of little pieces that I have here. So I came up with a slightly better way to square it up using a larger square that just skips all the pieces below it, but still not a very good system. Luckily, the squareness of the footstock is fairly forgiving. You don't have to get too crazy with it. Really what matters is the alignment with the center in that rotary table. For that, I set up an indicator. I started with the indicator horizontal, and I set it to 0 at one end, move it down to the other end, and I see I've got about 10 thou of difference there. If I can tap that error out on the footstock, I'll be golden. And I got most of it out after that first attempt, but I couldn't quite get it all the way out, and it's because the mounting bolts on the footstock are bottoming out on one side of the T-slots there. So again, a big mistake I made not using keys on the bottom of my riser block. I'm dealing with the T-slot clearances now. So the solution is I needed to move the rotary table over a little bit to buy clearance for the footstock. And of course, as soon as I did that, I had to re-indicate the rotary table because now it may not be square anymore after tapping on it. So again, use keys on the bottom of all this stuff and save yourself the grief. But after that, I was able to tap it in, and I'm now super straight here. I'm within a thou down the roughly 12-inch length of this bar, which is excellent. Now things are about to get weird though. I set up the indicator vertically now and I run the same test and everything seems okay. I've got a slight incline here that I can correct. But then right about here towards the footstock, all of a sudden the height shoots way up. And I thought, well, that's odd, but I'll work on taking out the overall angle there first, and I'll worry about that other anomaly here in a second. So I adjusted what should have been about right for the amount of incline that I had, and I wound it back, and everything was real straight, real straight, real straight, until all of a sudden it dropped way off again. So it's almost like there's a bend in the bar right at that one point there. I can fix the incline on either side of that, but not overall. And my first thought was, okay, the bar must not be a consistent diameter. That would explain this. But I measured it 4 different ways, 5 different times, and the diameter of that bar is perfect all the way down the length. So it's not that. And then I realized what was happening. The little shift is when the rotary table moves past the center point of the saddle on my mill. It's so heavy, that assembly, and this is such a light mill, that it's causing the table to sag when it goes over center. So the solution was a bunch of big heavy scraps on the other end for a counterweight. And that took out almost all of the droop, and now I'm able to dial it in straight all the way across. I've still got a couple thou of droop at the very far end there, but that's more than good enough for what I need in this setup. That setup is a lot of work, but I mean, we're basically building a lathe on the mill here. So honestly, that's not bad considering the difficulty here of aligning all of these different fixtures perfectly. The end result though is excellent, and this is super well aligned now, this setup, and I'm going to be able to do my operation in style. So you saw all of the design mistakes that I made in this riser block, not using keys. It should have been one piece, should have been bolted firmly to the footstock, etc. So I'm probably going to end up making this part over again with all of those learnings in mind, but I hope you've at least learned something about how to design and build riser blocks. Thank you very much for watching. If you like these videos, maybe help support me on Patreon. It's really the Patreons that keep this channel going. There's a link down below, or you can use the card there on the screen. Thank you for watching, and I will see you next time.